Sorry for taking such a long break. I had my own studies to do. So let's get back to question number 9. So we have f of x is equals to this, which can be written like this. Find the value of a, b, and c. We have two options. Either option 1, we convert this to that by factorizing, or we convert this to that by expanding. Obviously, expanding is easier than factorizing, so we are going with this. F of x is equals to x minus 2 whole squared ax squared plus bx plus c, a minus b whole squared, expanding, so x squared minus 2ab, which is 4x, plus b squared, which is 4, ax squared plus bx plus c. We multiply everything here by x squared, we get ax to the power 4, then bx cube plus cx squared. Then we multiply everything by negative 4x, so negative 4a x cube, negative 4bx squared, negative 4cx, then 4 ax squared plus 4bx plus 4c. Now we group everything like all the x cube and then all the x squared, then all the x, and yeah, ax to the power 4 plus, if we take x cube and x cube common from here, we have b left over and then negative 4a left over from this. Then we take x squared common. So when we do that, I'm writing the positive terms first, so it looks nice. Negative positive 4a, we left c there, c minus 4b plus 4a, then x, so which is this at this term. I'm taking 4b first, so 4b minus 4c, and then the constant 4c. And we have the original equation, which is f of x is equals to 3x to the power 4 plus, oh, I forgot x cube, x squared, and x, my bad, and then 4x cube minus 36 x squared plus 64. So that means this equals to this whole thing equals to this whole thing equals to this, and this equals to this, and this one equals to 0. So we have actually in here 1 2 don't forget the negative here, 3. This is 0 because there's nothing in here. There's basically 0x, that's why. So we have 1 2 3 4 5 equations. We can use any 3 of them because we have 3 variables. We need 3 equations. So I'm going to use the easiest one. Once, obviously, this one, a is equals to 3, and from here we get c is equals to 16, that's 2. Now we only need b. We can use this, 4b is equals to 4c, and then b is equals to c, b is equals to 16. So there you go, a, b, c, is equals to 3, 16, 16. If you want, you can use these equations as well. Now let's get to question number B. It says uh, figure 3 shows a sketch of part of the curve C with equation this. Okay, the C crosses the x-axis at M, O, and B. Okay, and lies on the x-axis between M and O. So we can say this, and A lies on C such that AN is parallel to y-axis. Okay, so the area of the shaded region bounded by the curve OB, which is this one, is numerically equal to the area of the shaded region bounded by the curve ON and this one. So these are numerically equal, given that the coordinates of n are n0. So this is n0. Use algebraic integration to show that n satisfies the equation this. So basically n satisfies the equation this, meaning we have to start here. Okay, the only place we will get n when we do integration of this part. So we have to do the integration of this part and somehow get to this equation. So let's first find the area of this part using integration. So we have B here. Oh, before doing that, I forgot. In order to find this, at these 3 points, y is equals to 0. So if we put that here, y is equals to 0, we get x into x plus 3 into x minus 2. So that means x is equals to 0, which is the origin, and then x is equals to negative 3, which is M. So M is negative 3, 0, and x is equals to 2, which is B, which is 2, 0. We will need this. So we have to integrate y. In order to calculate this area, we have to integrate y, meaning this equation, from 0 to 2. So we can call this A1 if we want. A1 is equals to integration of 0 to 2 y dx, basically. If we replace y with x into x minus x plus 3 into x minus 2 dx. Now we can't integrate this, so what we can do is we can expand this. We can expand this x into x plus 3 into x minus 2 x into x, that is x squared plus 3x minus 2x plus minus 6, x into x squared plus x minus 6, x cubed plus x squared minus 6x. So let's just put it here. X is x cubed plus x squared minus 6x dx. 0 to, we can integrate now. So x cubed becomes x to the power n plus 1 divided by n plus 1. So it becomes 4 divided by 4 plus x cubed divided by 3 minus 6x squared divided by 2. And the limits are 0 to 2. When we put 2, we get, you can simplify and then put the values, or you can just directly do it. I usually prefer to do it directly if it's simple like this. Totally up to you. Divided by 3 minus 6 into 2 squared divided by 2 minus 0, because when you put 0 in here, this term becomes 0, this term becomes 0, this term becomes 0. So you can just directly put 0 in here. So this becomes negative 16 over 3. Understandable, because it's on the negative side of the y-axis. That's why we have to take, we got the negative 16 over 3. But in here it says numerically equal. So we can neglect the negative sign when we are saying this part is equal to this part. So now let's do the same thing, but for this part. So I will just simply copy this whole thing. So this is A2. Instead of 0 to n, 0 to 2, we will go from n to 0. Yn, this is the lower point, this is the upper point. Okay, so lower to upper, n to 0. This is 0 0 here, so n to 0. So this is also n to 0. So if we do this at the end, you can directly write, we will get basically this whole thing, this part right here, but with n. So x to the power 4 over 4 plus 4 cube, sorry, x cube over 3 minus 6 x squared over 2, and this is n to 0. So when we put 0, we will obviously get 0, negative n to the power 4 over 4 plus n cube over 4 minus 6n square over 2. When we simplify this, we get n to the power 4 over 4 negative n cube over 4. Oh, sorry, this is 3, my bad. This is 3, this is 3, minus cancellation, we are left with 3n squared. So according to question, a1, value of a1 is equals to a2. We are only going to take the values, but since one is on the positive side, the other one is on the negative side, we can just write this equals to that. So 16 over 3, which we had in here, equals to this, minus n to the power 4 over 4 minus n cube over 3 minus 3n squared. We can move everything to this side, n to the power 4 over 4 plus n cube over 3 plus 3n squared plus 16 over 3. I think I made another mistake. This is a positive sign, because this was a negative, negative times negative, this is positive, my bad. So similarly, this is a positive sign and this is a negative sign. Now in order to get rid of the fraction, you can do two things. First, one option is to take LCM and then move the LCM to that side, or which I like to do is multiply the whole thing with LCM. In this in our case, LCM is 12. When we multiply this by 12, we get 3n to the power 4 plus 4n cube minus 36n squared plus this becomes 16 over 3 times 12, 64. And if you look closely, this is the same equation as this one, 3x to the power 4, 4x cubed minus 36x squared plus 64. 3, 4, negative 36, 64. 3, 4, negative 36, 64. And there is no n and there was no x. So n satisfied the equation. Now hence find the exact coordinates of A. So in order to find A, we need its x value and y value. Its x value is n. Once we have the n, we know A lies on this curve, so we can plot that n into this to get the y. Okay, that's the plan. So first task is to find the value of n. The way we will do it is using this right here, x minus 2 whole square plus into 3x squared plus 16x plus 16. But one more thing, if you look closely, answer for question A is given in your question in right here, so you have to you can use this to actually verify your answers, which is a very good thing. Now we have to write it like this. So let's copy it. Question number C, 3n to the power 4 plus 4n cubed minus 36n squared plus 64 is equals to 0. So we can write this like this: 3n squared plus 16n plus 16 is equals to 0. Where did I get this? It's in the question. In the question it was given as x. We are using it as n. So if we simplify, we can I think factorize this one more time. So 3 into 16 is 48. 12 plus 48 can be written as 12 into 4. 12 plus 4 is 16 as well. So 3n squared plus 12n plus 4n plus 16 is equals to 0. N minus 2 whole squared. If we take 3n common, we are left with 4n plus 4. No, we are left with n plus 4. And if we take 4n, we are left with, if we take 4, we are left with n plus 4. The whole thing is inside another bracket. Don't forget that bracket. Then we have n minus 2 whole squared into n plus 4 into 3n plus 4 is equals to 0. So that means n is equals to 2, n is equals to 2, n is equals to negative 4, n is equals to negative 4 over 3. Yeah, put the graph in here one more time. Let's look at this. N is equals to 2, which is right here. So this can't be the answer. So why did I write it 2 times? Because there's this. And when you see this, that actually means when you draw the curve of this equation of this equation right here, it will touch the n is equals to 2 or x is equals to 2 like this or like this. It won't intersect, it will just touch it. It will become basically x-axis will become a tangent. Okay, so that's what it means. So this can't be the value of n, because we know n is between negative 3 and 0. This is right here, so this can't be true as well. This is negative 1.33, so this is our answer. So n is equals to negative 4 over 3. And as I've said before, we can use this, we can since a is on C, we can use this equation. Okay, we know the x value, so we can easily calculate the y value. So y is equals to x, this is basically x value, x plus x plus, sorry, keep making mistake, x into x plus 3 and x minus 2. So negative 4 over 3, negative 4 over 3 plus 3, negative 4 over 3 minus 2. When you calculate this, you will get the result of 200 over 27. And that's your answer right there. So A is, this was the x value, so A is negative 4 over 3 and 200 over 27. Don't forget to write your answer like this, because the question asks for the coordinates of the point A.